So with conjugates, the idea here is to kind of get the difference of squares. This other stuff, it's useful, but in a math nerdy kind of way. So what we're saying is if you start with a binomial and then let's say that these had i's in them. So like if that was a bi right there, then this would be bi. So, or it doesn't matter which one you start with, but if you have these in a denominator, then you're going to multiply the denominator by the conjugate. Okay, but remember, if you do it to the denominator, you got to do it to the numerator. And what this does is it creates a difference of squares situation. But with the i's, you end up having a plus sign because it would have been really bi squared. And then the I squared would have been a -1, which would change that to a plus sign. So that's all this part's saying right here. Again, do you really need it? Not necessarily. Again, as long as you understand the difference of squares. So by multiplying conjugates of complex numbers, what it does is it gets rid of the I, which is what we want in the denominator. We do not want i's in the denominator. It gets rid of the I in the denominators. Oh, we have to use conjugates to get rid of complex numbers. There it is. Got it. You still have to use distribution or FOIL in the numerator, but in the denominator, this should come out as an individual number. Well, this one may be a little different. This one only says evaluate, and we want the answer as a complex number. Ah, geez. I guess I will do this twice. So I probably enjoy it more than you do, but there you go. All right, the first way I'm going to do this would be kind of with a conjugate in mind. So I'm going to do this here on the left. So in other words, I would take that 3i and I would multiply it by, you could say it is 0 minus 3i, but I'm just going to make it -3i. But if I do it to the denominator, I've got to do it to the numerator. So I'm going to multiply that by -3i. Now, just like we've done in the past, though, I'm just going to work with one at a time. And I'm going to start in the denominator, okay? So in the denominator right now, I've got 3i times -3i, okay? And this, maybe I didn't have to show that, but hopefully it helps. 3 times 3 there, that would be 9, and then I times I would be I squared. Well, I squared is the same as -1, and so I'd have to multiply that by 9.
9i squared?
Yes, thank you. Forgot my negative on the 9. No, I didn't. I apologize. I forgot the negative on that. So thank you, by the way. But now -9 times -1, that's going to be that positive 9 right there. Thank you. I lost track of that negative right there. So be careful. Don't make the same mistakes I do. Okay, now that evaluates the denominator. It gets rid of the I in the denominator, which is what we wanted. Now let's work with the numerator, though. Okay, so this would have been -1 minus 4i times -3i, and now I will distribute the -3i first to the -1, which would be positive 3i's, and then -3i times -4i. I'll show a little extra work there, but that'd be positive 12i squared, and the I squared specifically, right there, becomes a -1. So I end up with 3i plus 12 times -1, which is -12. So it's 3i minus 12, but to make this a complex value, I'll just put the -12 in front. So -12 and then positive 3i. Now, this is nice, and we did plenty of work right there, but it's not finished because it can be simplified. 12, 3, and 9 are all simplifiable by the same value. So what I'm going to do here is I'm going to split these up into 2 separate fractions, okay? So I got my fraction lines. It's going to be a positive 3i, -12, and these are divided by 9. And yeah, these can be simplified. They're simplifiable fractions. -12 divided by 9, that'd be -4/3. They're both divisible by 3. And then 3 divided by 9 would be positive 1/3. Now I'm going to set the I off to the right here. You can put it in the numerator if you'd like. It's the same exact answer, but for the most part, math nerds like to see it like this. I really don't care, but I feel the need to do it in a formal manner. So 1/3 I or I over 3 is the same thing. Now, because this one's unique, you get to see it twice. I just hope you enjoyed it as much the second time as you did the first time. Okay, because what I can do is I can rationalize the denominator. I can get rid of the I in the denominator just by multiplying the denominator by I. It's just if I do it to the denominator, I got to do it to the numerator as well, right? So here's what happens when we do that. Let's just work with the denominator. So that'd be 3I times I, which is 3I squared. And we know that I squared is -1.
I'm sorry, I lost it with the,
So, yeah, is this a conjugate? It's not, but you can see that I have, in fact, gotten rid of the I in the denominator this way. So it's just now a denominator of -3. And that's going to be interesting because, well, it's not interesting, but it kind of gets us to this denominator right away. So what happens to the numerator? Well, in the numerator, I've got I times -1, which would be -I, or -1I if you want. But then I'd have -4 times -4I times I, which would be -4I squared. And so then I've got -I minus 4, but again, we've got that I squared business going on, which is -1. And so I end up with -I, but now it's plus 4, because 4 times -4 times -1 is positive 4. And then just kind of switching the order there would be 4 minus I. And then you can see that this would give me the fraction, two fractions, with the denominator of -3, where I would have 4 and -I. Now, this isn't the same though, right? It's not quite the same here. That's because it's not fully simplified still. So right here, I would say, let's just, like that first fraction, let's just put the negative there in front, and then it matches what we have in blue to its left there. But this minus negative business makes that a plus, and then, like I said, I'll just put the I over here and just make it a 1/3. Same exact answer, just a different method to get there. It did need some simplification here. This one had simplification, but with the numbers. So if you ever have minus and then a negative somewhere in your fraction, just make sure you change it to a plus.